Hello everyone, my name is Invention. I'm currently doing my final year at Manipal International University, and today my topic is on rice husk biomass generated eco-enzyme as an effective non-chemical based surface sterilizer. Thank you very much.
Moving on for the introduction, Eco-enzyme is made from fermenting fresh kitchen trash or waste like vegetable and fruit peels. Fruit peels and vegetables are naturally and have been shown to own antimicrobial properties against a variety of bacteria, said by Salim and Said. The enzyme is also proven bioremediatory, used to clean environmental pollutions. Here is how we prepare the eco-enzyme. By adding 300 grams of rice husk into a container, and then add 100 grams of brown sugar or molasses and also 100 grams of baker's yeast, which is Saccharomyces cerevisiae, which is to speeden up the reaction of the fermentation. Then fill the container with 1000 ml of water and leave some air space for fermentation. Place the container in a dry and well ventilated area, therefore avoiding direct sunlight. After 3 months of fermentation, extract out the liquid and leave only the residue. Filter and fill out into different bottles. On to the introduction, chemical-based disinfectants used in the food industry usually contain harmful substances such as alcohol and heavy metals that contribute to food safety issues. Excessive use of alcohol-based disinfectants also can cause irritation by stripping away skin's natural oils. Nevertheless, rice is a widely consumed food crop on Earth, estimating consumption of around 500 million tons annually. With that, approximately 800 million tons of rice straw and husks are produced as residue bio-waste. Not only that, these rice bio-waste are usually burned to ashes, which contributes to significant pollutions in countries such as India, China, Philippines and Vietnam. Not only that, rice straw has been reported of owning antimicrobial properties against foodborne pathogens. Thus, the production of eco-enzyme from rice straw bio-waste not only mitigates the pollution issues, but also can serve as a natural, non-chemical based, safer surface sterilizer to be used in the food industries. Moving on to the problem statement, the disadvantages of chemical-based disinfectant usage in the food industries have necessitated the exploitation of natural rice straw bio-waste as a potential surface sterilizer. As my proposed solution, which consists of 3 objectives, which is firstly to prepare eco-enzyme made from rice husk straw, to evaluate the antimicrobial properties of the prepared eco-enzyme, and lastly is to evaluate the ability of eco-enzyme as food surface cleaner against the European standard.
For now, we're going to conduct the water break test by using 2 samples, which is the rice husk, 100% of concentration, and also our control, which is the Dettol. To begin with,
here are the result obtained from the water break test by using eco-enzyme, which is derived from rice husk straw and also the Dettol.
so now we would like to move on to the white glove test and also the tape test. So with this test, we have 5 samples, which is the rice husk 100% of concentration, and then the rice husk of 50% concentration, which is 25, third sample. Fourth sample is the control, which is Dettol, and the fifth sample is hand sanitizer. To begin with, spray the samples on the surface. On the glove and rub on the surface of the surface. Okay. So for the tape test, apply 2 cm of tape on the surface, whereby which is being sprayed by the sample. Upon applying, we can remove the tape and observe the stains, if there are stains on the surface.
Moving on to the functionality, as for the surface sterilizer evaluation test against the European standards, consists of 4 tests, which are the water break test, white glove test, wipe test, and tape test. The results here are obtained from the 4 tests conducted as mentioned. These are the results obtained from the 4 tests conducted as proven that the rice husk eco-enzyme has the same effectiveness as compared to the chemical-based disinfectant. Next, for the antimicrobial tests, which were performed using the microdilution method and gauging the MIC, which is known as the minimal inhibitory concentration. Foodborne pathogens tested were Pseudomonas aeruginosa, Staphylococcus aureus, Klebsiella pneumonia, Salmonella typhimurium, and Escherichia coli. From the graph obtained above, there were 5 graphs plotted against 5 types of bacteria as mentioned. As for the controls used in this experiment, which is the blank, MHB, Mueller-Hildebrand, and my positive, which is my sodium hypochlorite and also the bacteria culture, and also for my negative, which is the bacteria culture and also with the MHB, which is the Mueller-Hildebrand. As we can see that the rice husk ecoenzyme has significantly inhibited the growth against the bacteria used, except for Escherichia coli and also Salmonella typhimurium. For the originality, no effort has been made to generate ecoenzyme using biowaste such as rice straw previously. With that, rice husk straw generated ecoenzyme has not been evaluated for its antimicrobial activity against foodborne pathogens and has not been tested as a potential use for food surface sterilizer in the food industries. Next, we would like to talk on the cost effective for the bulk production, whereby the cost of ecoenzyme can be more cost effective. As you can see from the table above, it shows that the ecoenzyme can be obtained as free due to its biomass waste. As for the molasses or brown sugar, it is only required 300 gram, therefore it is only 1 ringgit 20 cents. And for the baker yeast, which is only used around approximately 100 gram, which is 2 ringgit 50 cents per packet. Therefore, the total net price is around 3 ringgit and 70 cents per liter. Moving on, for the commercial potential, the use of food surface sterilizer in industries such as fast food restaurants such as McDonald's and KFC, street hawking where there is a high risk of foodborne pathogen contamination, and lastly, the domestic use of cleaning, cooking area and food surface.